So welcome back to chapter 5. We are talking about types of heat transfer. And first we talked about conduction. And then the second type of heat transfer is convection. And this is when heat is transferred by moving air or liquid currents through and around food. And so this is the primary way that heat is transferred for baked goods. This is really important, convection heat. So a regular oven will transfer heat with radiation from the oven walls and to a lesser extent like natural convection that's caused by temperature differences throughout the oven. But a convection oven in particular has an air circulating system, fans, that help circulate the air. And this could be detrimental a bit because the moving air can cause foods to lose moisture and cake batter to be prone to bake with uneven tops. That's supposed to say bake, not back. And with a convection oven, you do want to decrease your temperature by 25%. But the idea of a convection oven is because the fans are circulating the air, you're going to get a more even bake, which is really nice, except for cakes. It kind of just depends on what you're baking, if you want to use a convection oven or a or the regular type of convection. So they both cook with convection, but a convection oven specifically has the circulating air versus radiation coming from all sides. So if you think about it, like a cake is going to bake, the top of a cake needs to bake really evenly, but the sides of it are held into the pan. So you're not really going to get much of a difference if you have your heat sources coming from each side of the oven. Whereas something like bread that has nothing surrounding it, it's like a loaf, a free-form loaf, will be very beneficial from a convection oven where the heat is moving around that bread. So, I mean, it really just kind of depends. I actually recently just got an oven that does both convection bake and regular bake, and I'm playing around with it. So I'll keep you posted to let you know. I made muffins yesterday and they did come out really beautiful with the convection bake. I found that like if I want something really crispy on the outside, the regular bake is better than the convection. But like I said, playing around with it, I'll let you know. So there are some other convection methods as well. Simmering, steaming, deep frying. They all use both convection and conduction to cook. Because the air is circulating through the food. I mean, the heat is circulating around the food. So when you're simmering, you have all those little tiny bubbles moving around the food. And the heat is coming from both that conduction, the burner of the stove, interacting with the bottom of the pot, interacting with the liquid, but it's also using the convection of that heat circulating through those bubbles. Let me know if you have any questions on that. This can be kind of a challenging one. Oops, sorry about that. So next is radiation, and this is the transfer of heat energy in the form of waves of particles moving from the source outward, or electromagnetic waves. And so this is the type of heat transfer for broiling, grilling, and microwave. And another way to transfer heat with radiation is actually through infrared heat lamps. So if you've ever been in a professional kitchen, a lot of times they have a heat lamp to keep the food hot while it's waiting to go out into the dining room. So the food will be cooked and then put underneath the heat lamp. And since that is still heating the food, you always want to be sure, like if, for instance, you're cooking a steak, that you take it out a little bit sooner than you want it done because that heat lamp will continue to cook it. So radiation is one of the controversial cooking methods because people have a negative connotation of radiation due to the fact that there are links of very high exposure of radiation and cancer. But this is the type of radiation you see from like an atomic bomb explosion, not the type of radiation you're going to see from cooking with these methods. So just remember that. So induction is the last heat transfer method. And induction is using heat energy without direct contact with coils. So what you're actually doing is using an electromagnetic field which generates heat. So if you've never seen an induction burner, it looks like an electric burner. It's a flat surface. It's usually looks like glass. but it doesn't heat up and get hot like an electric stove would. In order for you to cook the food in your pot or pan, you need to have a specific type of pot or pan. It has to be iron or stainless steel. And what happens is that pot or pan interacts with the magnetic field and cooks the food. So the burner itself doesn't actually get hot. It's just that pan that gets hot. So this makes it a really great option when you are cooking with kids, for instance, or going into a place where you cannot bring a live flame. So works great for cooking in a classroom, for instance. But you still can the kids could still get burnt, because if you touch the pot itself, you'll get burnt. But as soon as you remove that pot from the flat top, that flat top is not, it's cool to touch. And the coils just transfer the heat to the pan. And then the pan itself transfers the heat to the food, the same way that it does with conduction. I apologize, my dog is barking in the background. So if you've never seen an induction burner, I highly recommend looking it up, because it's a really good option for dietitians when you're doing food demos. So moving on to how we measure heat. So heat's measured with Fahrenheit or Celsius or centigrade or the Kelvin scale, which is mostly used only in scientific research. So for water, I'm going to review these points because we already talked about them last chapter, but really, really important, maybe a test question. Freezing point is 32 degrees Fahrenheit or 0 degrees Celsius, and boiling point is 212 degrees Fahrenheit or 100 degrees Celsius. And these extremes owe their effects to kinetic energy, which is energy associated with motion. So heating is going to be an increased motion, where freezing is a decreased motion. And the molecules are specifically what's moving. And I think we already talked about this pretty in detail during the water section of chapter 3. But if you have any questions on that, please let me know. You will need to know Fahrenheit and Celsius conversion for this class, which we will talk about in next week with Unit 2 lab. So let's talk about knives. So a chef knife or a French knife is the most common knife used. I'm sure you've all seen it, and it is like a great all-purpose knife. When you're holding a knife, you want to put your hands around the blade between your thumb and your forefinger, and your other finger should be held tightly around the handle. You can have your thumb pointing up towards the blade. But I always tell little kids, especially if they have not cut before, to make a fist and hold it like a baseball bat, because you're going to get the most grip that way. But if you have used a knife before, you want to hold it in this manner described here. That's the more advanced way. And positioning of your food and grip influences the degree and control of leverage. So light tasks such as cutting the stem off a tomato or having cherry tomatoes, or trying to think of what else, de-stringing some celery, that you're going to use the tip of the blade, or you're going to use a paring knife, which is a smaller knife. Some harder tasks such as chopping a squash, like cutting down on a squash or cutting the base off of a carrot, those are going to use the back end of the knife. So anything that's going to take some leverage. And also you're going to use the back end of the knife for mincing. So when you are cutting, as you can see, there's that demonstration of the your thumb and your forefinger on the blade. And like I said, that's if you are pretty advanced with your knife skills. If you've never held a knife before, I want you to grip it like a baseball bat, because you're less likely to slip and have that finger go underneath the blade. But how you want to hold your other hand is what's really important. We call this bear claw when we teach the kids, and it's a really great way to remember it. I will call it bear claw when I do some knife skills videos for you, or if I share some from my chefs. And you're curling your fingers under so that you protect your tips from being cut. And this is super important. If we were in lab together, I would go over this 100 times and walk around to make sure that you are doing it correctly. Because the last thing you want to do is cut the tips off your fingers, right? But if you hold your hand this way, the worst you could do is nick your knuckle. So again, so delicate work, like slicing a mushroom, you're going to use that tip. All-purpose work, slicing, we didn't talk about this. This part, you're going to use the middle of a knife. And then for something really hard to chop, like the base off of celery, you'll use that back end. So why do we want uniform pieces? I guess maybe it's an obvious answer, but maybe not to everyone. The reason you want uniform pieces is because you want everything to cook uniformly. You don't want to have a big chunk of squash and then a really tiny chunk of squash, because that little tiny chunk of squash is going to be overcooked by the time the big chunk is cooked, if that makes sense. So there are some different types of styles of cutting. And I think I have examples of all of them in here, but I will also try and provide, there are some knife skills videos on the on Moodle already, and I'll also try to provide some other videos with knife skills, because this is really important, and this is probably the only place in this program where you'll get knife skills. So slice is using the tip of the blade, and that stays on the board while the food is being moved under the back of the blade. Not the very, very back, but like more like the middle. A bâtonnet is to slice food into 1 to 3 inch long and 1/4 to 1/4 inch wide. Julienne is cutting into 1 to 3 inch long strips that are a 1/16 to 1/8 of an inch wide, so thinner than a bâtonnet. Shred is going to be to cut leafy vegetables into strips. You might do this with cabbage, sorry. Dicing or cubing is to cut them into exactly what you would think of, or cubes. Mincing is to chop into very fine pieces. My husband always forgets what the word mince means. He always wants to dice for mince, but mince, it means like very small. And the way to remember it is, if you've ever heard mince meat pie, it's meat that's been chopped up very, very fine. So peeling is removing the skin. And then chiffonade, which is my favorite knife cut, it means ribbons, is to roll up your vegetable or an herb. This works really nicely for baby spinach or basil or kale leaves, and you roll it up like a burrito, and then you slice it into ribbons. Oops, and I went the wrong way. Oh, no, I didn't. Oops. Oh, now I'm really going backwards. Okay. So start with your blade tip down, press down, and pull forward simultaneously. And as soon as your blade touches the board, you can move it up and then keep going for the next slice. And so here are some of our pictures. So there are rounds or slices. Then you can also have diagonal slices. A mandolin, this is an instrument that's used to cut especially very, very thin slices of things. So it also could be great to cut strips, so like French fries. But the thing is with a mandolin is it's incredibly sharp and very dangerous. People oftentimes cut their finger because they don't realize that their vegetable or fruit has gone down so far, and they just go right down and cut their finger. So that little black thing that's next to the mandolin, that is a guard, and you punch that into the food and use that so that you keep your fingers safe. So here's your bâtonnet, and you can see that's a strip, but it's a little bit thicker. Your julienne are going to be like matchsticks, very thin. Shredding is right there, and then chiffonade is when you roll it up and you cut it like that. And then again, mincing, it's to cut into really small pieces. And again, I'm going to try and find videos for all of these so you can see them. And this is how to dice properly, and I will definitely show you guys a video how to dice an onion, because I don't think that this picture really does it justice. Here's a really commonly miscut fruit, technically. Avocado is a fruit. It is how to cut an avocado. And you want to be very careful. Trying to get the pit out of an avocado is one of the most common reasons people wind up in the emergency room, actually. So you slice it around and then you move it, and then you use the base of the knife to get out the pit. And there's actually a safer way of doing it, which I could show you a video of